Hi, everybody. It's exciting to be here. Always excited to come to a meetup and talk to the community members. It's one of the fun things to do. So thank you for coming over. Uh, oh, it's okay. Okay, I have one slide, so I don't need this anymore. And there's a lot of things I think that I can talk about. Hopefully, some of you that were here, that were at the conference yesterday, heard about the work that we're doing in vector search and Gen AI and retrieval augmentation generation. And if you want to, you can read about it online. Tons of good stuff happening there. Another interesting and very exciting area that we're developing that is new in Elasticsearch is ESQL, the Elasticsearch query language. So if you get a chance, I urge you to go and read about it and learn about it. It's a whole new query language for Elasticsearch. Very user-friendly, easy to use. It's a pipe-based language. But what I wanted to talk about was one of the first things that I went and tried to address and change when I moved back to be a CTO at Elastic. So I was one of the founders of Elastic, the company. Started as a CTO, then moved to be a CEO of the company, took the company public, moved to the US, did a lot of things, and then I got demoted to be a CTO again. I'm joking, but I went back to be a CTO for a few reasons, but the biggest one is that I felt like I wanted to get back to connect with the technology aspects, and I felt like I'm always thinking about what's the biggest impact that I can do in the context of Elastic. And it felt like there was a lot going on, and the biggest impact can be for me to go back and focus on technology. And it wasn't that I wasn't focusing on technology before, but being a CEO, there's a lot of other things that you have to go and worry about. So one of the first things that I try to focus on is, and I tend to think about like bottom up, like the most fundamental changes that we can potentially do in our product or architecture, that any change there ends up being very impactful, right? It's like it drips over to, or drips down, or drips up to across all the architecture. It makes a big difference to users. And one of the things that I was thinking about was Elasticsearch. I mean, I wrote the first version and a few more after that of Elasticsearch, probably responsible for the biggest part of how it works at a fundamental level, inspired by distributed data systems and data stores, sharding, taking data and partitioning it, replicating that data, keeping it locally, still being highly available. If one machine dies, then go and redistribute the data and move the shards around and things along those lines. Very much similar architecture that many NoSQL solutions out there were having as well. And obviously try to implement it in a very easy to use way. And I think one of the reasons why Elasticsearch was so successful was that it was easy to use. You just like started up and it just started working. It would even at one point was doing discovery over multicast. So people were starting Elasticsearch in the office, and it was like creating a single cluster, and there were like a lot of fun stories around it. But things change in the industry in terms of architecture of data stores, and one of the biggest changes, and it's called, for the lack of a better term, cloud native architecture. I hate that, but I'll go with it for a second. But a few things change in that area, and a big reason for that change is how mature the object storage have become. So S3, Google Cloud Storage, Azure Blob Storage, they have become extremely mature in terms of their capabilities. You can rely on them, for example, for things like read after write. So if you write, you can guarantees for you to do reads afterwards and things on those lines that really allow you to start to build more sophisticated systems on top of it. And the newer age architectures of this cloud native architecture takes that and put it at the forefront, like really rely on them as a big part of their architecture. So let's take a few examples here and explain how things work. So in Elasticsearch, for example, today is the existing architecture. If you index data, it goes to a primary shard, right? This hot primary over here. It goes to a primary shard. The data gets indexed. It probably gets replicated because you want to have persistency. So it sends the document over to the replica and replicates that document, persists it, writes it to a transaction log, f-syncs that transaction log. There's another system that writes the data in a parallel thread into Lucene with segments and things along those lines. And every second it refreshes the system and make the recently indexed data available for search. It can age systems, so it can move them to a cold tier or frozen tier, which I'll touch in a second. You can snapshot the data to an S3 storage. So it's not about relying on the S3 storage. And I'm using S3, but I really mean any blob storage because we support all of them. Also on-prem one, I'm using something like MinIO. But you can snapshot the data to it. It almost works like a time machine, right? It's like it snapshots the data and then snapshots again the data, but it's not the full data. It only snapshots the delta and the delta and the data into S3. And one of the things that we did a few years ago is that we introduced a frozen tier. That was like the first really embracing an object store as a more critical component in the system. The frozen tier in this architecture can go and search on S3 directly. You cannot write into the frozen tier. It doesn't support writing into the system. It doesn't support changes. The idea is that data ages in time-based data. It's mostly around like long-term storage of logs or security events or things like that. And at one point, it doesn't change anymore. And then you can move it to the frozen tier, and then it works with the snapshot data that you have in S3, and it can go and search it, if that makes sense. But still, if you want to go and change something, you need to bring it back to the hot tier, index the data. There's still 2 replicas and things along those lines. Obviously, read-only in the frozen tier, you only need 1 shard to go and read it. It has some caching mechanism, but mostly searches just work on S3, basically. But this is still like the storage system itself is not at the forefront, right? If the whole system goes down, let's say all the machines disappeared, you have a backup in the snapshot and restore, but that's based on the schedule that you did. The data that aged into frozen, that's okay. That's still there because it doesn't change. But that's how the system works. It's still heavy, right? It's like when you index data, you have to index it twice, for example. It couples together indexing and search. So when you go and index data and then you want to search the hot data, the indexing operations and the search operations compete between themselves on resources. If I want to go and scale search, I, by definition, also have to do more indexing. So if I want to have now 3 replicas of the data or 4 replicas of the data, suddenly now I need to index data 4 times or 5 times. So there's things that, it works well. It's a system that scales. It's like, I think amazing things have happened with it, but it has these challenges, and potentially we can do better. So we got together as an engineering team and started to try to figure out if we can move to a new type of architecture. This new type of architecture, it's not rocket science, to be honest. Like, it's relatively straightforward in terms of how it's being used. You put the storage itself in the middle, that's S3. And then you have an indexing tier that indexes the data and puts it into S3. And you have a search tier that knows how to take the data from the S3 and make it searchable. It's not rocket science. This is like a very common architecture that people use, especially in data stores. It's a very tricky one to implement, especially for a search engine. Search engine, like Elasticsearch, it's a very rich experience, right? It's like you index data. It gives you full text search. It also gives you vector search. It does columnar storage. It has big AD tree for geo and numeric filtering and searches. It's a very, it's a system that has, a lot of different data structures behind the scenes, from column store to big AD indexes to FSTs for an inverted index to dense vector based on HSMW. So it's a lot. And there isn't, at least today, a search engine out there, at least in the open source world or in the open world, that has this architecture, because it's pretty complicated to go and implement something like that. So the biggest challenge that we had was to try to figure out how do we implement and go and make Apache Lucene and Elasticsearch work with such an architecture. And a few things happen here. So the first part is, and I'll just talk about the benefits of this architecture for a second. When you index the data, you only have to index it once, regardless of how many times you want to search it or something along those lines, because you index the data and then you upload it to something like S3. That's amazing, because then you only index the data once, regardless of the systems that you have. You can still partition the data, obviously. You can still figure out how to do concurrent indexing, but you don't have to go and have replicas, if that makes sense. When you want to go and search, you can just have one search process. You can have two. You can have 100. You can have 1,000. They're very lightweight. They search on S3. Obviously, that's slower than searching on SSD. You know, yeah, we can't make that. We can fix that, but we can do smart caching and figure out how to pre-fetch data and data structures that we know that are almost used or most commonly used and things on those lines to make those searches more interactive. By the way, our users have great experience with the frozen tier over there, so we know that that's already pretty great, right? It's like from our experience, at least, our frozen tier is faster than Splunk, for example. So like that's the speed and scale that, if you're thinking about it. So this is the search tier and how it works. The nice thing about this, we can bring all of this down, and nothing gets lost. I'll talk about the corner cases that you have to worry about, because it's all in S3. And then I can bring it back up. And suddenly, things just start to work, if that makes sense. That makes the system more lightweight. It's like one of the things that was nice about Elasticsearch when it started was it felt easy. It felt lightweight. Just fire things up and it just worked. And over the years, we expect more of our software and our products. It starts to feel heavy. Even when we manage it on our cloud and things along those lines, it feels heavier. It's like, it's existential to remove a node from a cluster, because it starts to move things around and it's expensive and it might create noisy neighbors experience and things along those lines. And then if you add another node, it repartitions the data. Now, all of these things work, but they're heavy, like they're noisy, by their nature, right? You move things over the network and things like that. Here, there's much better separation and decoupling of operations. I can start another process for indexing tier, and that's perfectly fine because it only happens once, and partition the data. I can start 1,000 search processes, and that's totally fine because it won't affect indexing. And it's very lightweight. I can go and shut it down, bring it back up, and things should work very quickly. The biggest part that is going to take time for it to fire up is this caching tier, right? It's like this caching that the search needs to do as it fills up the caching. Yeah. There's no primary, no replica. There's only one shard. Like not one shard, but there's like one. Here, think about it like shards become the things that index the data. So they're still index. They're still shards. You need to worry about them less because they're not as existential. And the shard index the data. And here there's the same index 1 or index 2, that has a shard. That is the search shard. So you have an indexing shard and a search shard. And you can have 100 search shards, and you will always only have one indexing shard because you don't need any more. No. I'll tell you why, though, because this is where things get tricky. But yes, in practice, in our architecture, you won't lose data. This is S3. S3 already has replicas. S3 already has copies of the data. Relying on S3. So this is like completely relying on S3 as the storage of the system. So data relies on. So all the data is on S3. Yes. So what is the index? Yes. So the indexing, the question is what is indexing tier and search tier? Are they just the compute? They are just the compute, but they still need some storage. Why do they need storage? The search tier does caching. So they cache, you don't want to access S3 every single time. So it's important that you have good caching semantics and mechanism. I'll explain, if I have time, I'll get into some of how we do caching and things along those lines. Sometimes you want to have 100% cache, especially for like high search workloads. That's totally fine, but it's still, it's the main copy of the data is here, but you can have 90% cache or 80% cache. You're getting into the details of the architecture. The short answer is yes. Yes, you can control what's being cached. At what level? The way that we're going to ship it is we try to give you less control and try to be smart, right? It's like people always like I want to be able to, I know that this segment file is the one, but then when you give a lot of control to users, then you sometimes shoot yourself in the foot because you can't do optimization afterwards, because so much of your architecture is linking to the system. So we're going to give some control, and I can talk a bit about that, but we're going to start with very high-level control and then figure out how much control do we give. Yeah, so this is what we call it internally stateless Elasticsearch. I think you know why it doesn't store state. This architecture is only going to be available in our cloud to begin with. As you can imagine, there's a very intimate work that we're doing with the blob stores. We're working with AWS, Google Cloud, and Microsoft Azure. But we're finding bugs in Microsoft Azure Blob Store with this architecture. So we're working with Microsoft team, for example, to fix them. So there's like a very delicate requirements from the Blob Store to make this thing work well. It's a much more complicated thing to make work from, I don't know, something like ClickHouse or Loki or other systems because of the richness of the API of Elasticsearch, as you can imagine. It's not like full table scan or full columnar storage scan. Like there's a lot of intricacies around how you reach it. One thing that I would say, it's a bit of a mind bender, but I love it. When you have systems that are dumb in terms of how they access the data, something like a Loki or something that has only one pattern of access of the data, like ClickHouse or something along those lines, then when you index the data, then it will know how to reach what it needs. But sometimes if you miss how you go and search it, or it's not an operator that it supports, it ends up doing full table scans of the data. As you can imagine, when your data is on S3, full table scans are going to be very expensive. And they're going to be very slow. They're much slower compared to SSDs. In Elasticsearch, by default, we index everything. I like to say, imagine that you went to a DBA, a database administrator, and told them, I want to create me a table in Oracle with 100 columns, and every single column has as an index. They'll throw you out of the door. I go, are you crazy? Every column has an index. It's expensive. It's going to be slow. It won't be useful because Oracle will only know how to use one or two columns in the index. By default in Elasticsearch, everything is indexed. By default. And sometimes people complain about it, right? Because they say, oh, it's slower to index data compared when we write it to Loki. Of course it's slower. It indexes everything. It's like I like to say that you can always make us as fast as others by not indexing stuff, for example. It stores more data because it indexes and has all of these index structures. If you wanted to do full compression, then don't index anything, and it will go back to do full table scans. The benefit of indexing everything, I think, is going to be much more significant when you do S3. Because regardless of how you access the data, we won't do full table scans. And that might end up being cheaper. You might be going and saying, well, I won't index everything, and it's going to be 0.7 or 70% of the data reduction, or 30% or something along those lines. So I'm saving on the cost of the storage, But the API calls, when I use the system all the time, it's going to make it expensive. You might go and say, well, actually, it's worth it for me to store 130% of my data because S3 storage is relatively cheap. And it means that I'm going to do much less API calls when people go and access the data. I don't know that that's a theory. We've tested it in the lab, obviously, and things on those lines. We'll see how it works in practice. But this is one of those where it's a bit, it's better to index everything. It's better to store more because it's going to be cheaper. It's a bit contradicting, if that makes sense. Yes, yes. No, it's not a difference. But suddenly it becomes even more significant with this architecture, especially compared to other systems that have a similar architecture. Yeah, so I'll talk a bit about some of these things. The first one is there's a lot of delicacy of how this works. We still need to have a transaction log. When you do an operation, we want to make sure that when we ACK it back, when we send it back, we have written something to S3. So there's a lot of work that we're doing around batching of operations, writing to S3. Today we use S3 also for the transaction log that we have in the system. So the guarantees that we have in Elasticsearch, we're going to maintain. Same thing with the index store and writing and things on those lines, uploading segments of Lucene segments if you know how it works. The search tier obviously sees these new Lucene segments. It pushes and this one might give it hints and tell it, hey, go and search. It's ready for search. There was new data, so this needs to refresh itself and so it can have access to the new segments and the new data that there is. A few things that do change in this architecture. Here you index data and it's here. You don't have to wait for it to move to somewhere else to be able to go and search it. All you need to do is refresh. And once it's refreshed, it's available for search. Here it goes through, it has a journey. It gets indexed, needs to get to S3. So suddenly there's an S3 in the middle, and then it becomes available for search. That's a more expensive flow of data, if that makes sense. Eventually it's the same, because if you would do snapshot and restore, snapshot here, so you end up writing about the same amount of data to S3 if you want to do backup to S3. But the path from indexing to search takes longer. Now we're working on improving it and making it faster, but you can't walk around the fact that this is in the middle. So if you were used to a refresh interval of 1 second here we're probably going to default to 10-second refresh interval. So when you index something, it will be available for search after 10 seconds. In some situations, you can reduce it to a lower amount, but it's going to become more expensive, if that makes sense, because it will imply more segments being written at a more frequent pace to S3 and then being searched here. Someone had a question. Oh, yeah, sorry. Yeah. Yeah, so we're focusing on this for our Elastic Cloud. So it will be only on our Elastic Cloud to begin with. And Elastic Cloud will be available on AWS, Google Cloud, and Microsoft Azure. Being able to go and run it on-prem or in a self-managed environment, to be completely honest, we're not even thinking about it now. We're focusing on implementing this pretty significant architecture change in Elasticsearch, and then afterwards we'll try to think about what we do in the self-managed world. So I suspect that for the next year or two, this thing will only be available on our Elastic Cloud. Yeah, so there's a question about significant cost reduction that happens here. There is. You only index the data once. So obviously the indexing tier is cheaper. You do more operations around S3. So refresh intervals ends up becoming more expensive and refreshes operations. So you do end up doing more operations around S3 to write new segments and transaction logs, transaction log operations. The search tier and the indexing tier can much more easily scale down to 0 and scale up. So we can be more aggressive in terms of scaling down and scaling up, hopefully without the customer knowing about it, or you can tell us if it's okay to scale down and scale up. And that means that we can, obviously it costs less, if that makes sense. Generally, this architecture is cheaper compared to what it is before. But there's still at least a year, if not more, worth of additional work that we need to do in terms of optimization to achieve all the opportunity to make it cheaper. For example, now maybe we're abusing S3 as a transaction log, so we might end up using another system that is cheaper for it, for example, for a transaction log. So there's some areas that I think we can even improve the cost even more. Yeah, there was a question over there. Yeah.
Shiva, I have a question here that since we are storing the index on the object storage, so what about when we are talking about role-based access control and trying to search for data, is that control still going to be with Elastic, or are we going to rely on the IAM policy of AWS since we are talking in S3?
Now is on Elastic, because these are still the same index file, segment files in Lucene or something like that. So you still rely on things like document and field level security and filters and what have you. Our architecture still, yes. So that's how it works. We're working on this architecture in parallel to add bring your own key and other stuff. And obviously you can create a deployment on our cloud per customer or per this, and you can control it. You'll have the same flexibility here as well.
So, and also one another question here, that when we are searching for data, and we have seen like some people want to change I not say directly the mapping, but as a part of runtime, part of runtime fields and tailless scripts. So that would be performed via search tier.
Yes.
And won't that cause a performance issue, because then it would have to some way interact with the indexing tier?
Oh, no. So when you search the data on the search tier, it only accesses the index store. So only S3. It's not interacting with the indexing tier.
What if sometimes during this, if the search is complicated and we are using some, let's just say, painless scripts or runtime?
So if runtime fields is being used, or painless scripts or things along those lines, it will still be done in the search tier. It's part of the search request that you provide. Searches only go to the search tier, and they only search on this on the S3 store. By the way, the good news here, ESQL, it's much faster than the search, the current search API, because we can parallelize the operation, and it's going to make it much easier for you to not need to use runtime fields and painless scripts that are painful to use. They are painful to use today. So hopefully you have a much better experience with ESQL also moving forward.
So just a minute, how are we doing on time?
We are actually running out of time, but yes, we can take
let's take a couple of questions, please. I think you had one question here.
Yeah.
We'll come around to that.
Yeah.
So moving forward, for future versions, will Elastic Cloud support both architectures?
Yes. So our plan in Elastic Cloud, this is we call this hosted, and this is we call serverless. This is going to be here for 20 years. I don't know. This is going to be here for 20 years and a half. But yeah, both architecture are valid. This is going to take time to mature. It's going to take time to support it across all cloud providers. It's going to, we just deployed a private beta on only on AWS because we know S3 the best, and only on one region in the US. So it's going to take time. This comes, by the way, with a big re-architecture in other places. We're re-architecting all of our cloud to run on Kubernetes, on Elastic Cloud on Kubernetes, on ECK. We are taking more responsibility. This is going to be fully managed, versus this one is more of a hosted experience.
And so how is it? Will I have an option to move between these two?
Yeah, that's a great question. Not now. But our plan is that this snapshot and restore will be very similar to this. It's exactly the same. So we'll be able to go and either create links or copies from this S3 to this one, and then you'll be able to migrate to it. One more important thing, if you're an Elastic Cloud customer today, what you're buying is not really this or this. What you're buying on Elastic Cloud are credits. And let's say you buy $1,000 credits, and then you start to use this, and you get $300 and you're using it, and suddenly you want to migrate to this, you still have $700 worth of credit to use it. So you don't have to wait for this architecture to start use our cloud service, and when this is ready for you, we will allow you to migrate seamlessly to this experience. One more thing that I want to say, it's important. Someone asked me if these clients are going to stay the same. We took the opportunity to clean up our APIs as well. We've been more aggressive in cleaning up the APIs compared to less. We kept Search API the same, Index API, Bulk API, and things like that. But other things like node stats and things that really expose that Elasticsearch exposes a lot of the architecture and how it works, we removed them. Because we really want this to become a more serverless experience. So the less we expose the guts of how it works allows us to go and optimize it. And our idea is that at this point we prefer to remove more, and then we didn't remove it from the code base, obviously, it's still there. And then see what we get from the community and from our users, and then understand what we need to add or what we need to change.
Sure. I think one last question, please.
Yep.
So we'll let Shay go. We are not shy. Ashish, me, myself, and a few of us will be around to take more questions.
It's okay, no worries.
So yes, please.
What's up? Yeah.
So, will it be able to handle latency-intensive applications like content search or e-commerce search?
That's a great question. So there's a question about whether it will be able to handle latency-intensive application. We introduced a new concept here that we call search power. So we're trying to abstract things away. Obviously, if we were exposing all the low-level details, every index will have how many of it is cached and how much of it is not, and things along those lines. But we introduced a concept called search power. Let me take a step back for a second. Low latency application probably need 100% of the data cached on SSDs. Once you hit S3, it's going to be, suddenly it's going to be slow. So you want to make sure that all the data is cached on SSDs, and you're enabling shards to accept searches when the data is cached. That's perfectly fine. By the way, there's a chance that maybe even for these low latency applications, 80% cache would work for you, right? So it's going to be up to you to play potentially with that. The way that you play with it, it's something that we call search power. So you'll be able to say 80, 70, 60, 90, 100, where 100 means 100% cache. And then if you go to 200, it means that we're going to put more juice behind searches. For example, by increasing the number of replicas or things along those lines. Now we're still playing with the definition of the search power, but will basically be something that you control. Search power is slightly more complicated than I just said, because search power really works with two areas of your data. You're going to have one area that is interactive, as you said, and another area that is non-interactive. So this allows you to still maintain something like the frozen tier and the hot tier. So search power will, if you put it at 100, then 100% of the interactive tier of the data will be cached, and about 5, 10% of the data, maybe 20, depends. And then as you change, it will be on the frozen tier, on the non-interactive tier. So this really works for time-based data. Right? And you'll be able to change it, go and change it on the fly. Obviously, both the interactive tier timing, like the window of time that it has, and the search power itself.
Was there any improvement in has parent, has child queries, like join queries?
No, it's the same. So has parent, has child remain the same.
Any alternates?
The behavior of searches remains the same. What we have done, but this is also, we're running it here, when it comes to performance of searches, that will apply in some cases. If you think about this architecture, the more concurrency we can do in parallel against the index store, the faster the more throughput you can get. Not more latency or less latency, more throughput, because I can parallelize the searches and the fetching of the data. So this type of architecture means that if a single shard, if we can make it more concurrent, even for a single search, that's going to be much more significant for you. So we've been working over the last few months to introduce concurrency on the shard level. not across shards. So a single search on a single shard will now break and execute concurrently across the segments that you have in Lucene. And the next step that we're working on now is, regardless of the segment, it will execute concurrently based on the number of threads, the number of cores that the system has. That means that some of your search, we blogged about it, some of your search operations will be much faster. I don't know about has child and has parent. Those are more complicated ones to do. But aggregations and regular searches are now concurrent, and we're seeing like great results with it, especially vector search based, HS and KNN based queries are significantly faster in this concurrency model. But this rolls out here, but we're rolling this out here. So once you upgrade, you get the concurrency, and you get the experience, and you get the features.
Yeah, when the new architecture will be available, like what's the timeline?
It's a tough one to answer. We just started a private beta, and we're starting to gather feedback from like a selected few customers that are playing around with it. I don't know. It's very hard. This together with migrating to Kubernetes, together with changes in other parts of our architecture, it's the biggest architectural change that we've done in Elasticsearch ever. So it's really, it's one of those things where there is known unknowns. Like I know that there's going to be things that are going to break, and we need to figure out how to fix it and optimize and batching and this along those lines. My personal hope that within a year this will be stable and we will provide it across all cloud providers in the major regions that we support. Maybe not in all the regions, but in the major regions. But we're gonna start to do it in phases, and we're gonna try to get users to start to use it as quickly as possible.
Sure. Thank you, Shay. I think.
Yeah, awesome.
Thank you.
Yeah.
I think.
Cheers. By the way, this is just one small big thing that is happening at Elastic. There's a lot of progress. Like this is one of the most exciting times that I've had a chance to see that is happening in Elasticsearch, in Elastic, the product line in general. ESQL, go and check it out. This concurrency thing, I just mentioned it offhand. We've been working on it for the last 7 months, both in Apache Lucene and in Elasticsearch. So there's tons of exciting things happening. Gen AI, dense vectors, quantization, tons of exciting things. So follow up. It's an exciting space, and we're moving fast. Cheers.
Thank you.